So today we're going to see how how does a jet work? How does a jet? Okay. So how does a jet work? Or actually, a how yeah? How does a jet work? A jet or a rocket? Rocket. Okay. So well, the rocket we can see over here. What happens is that it has its mass, has fuel. There is the combustion, and the combustion it goes out. The exhaustion is, as you can see over here, smoke. So the smoke, as the second law of Newton, makes force down, so the rocket goes up. So it makes a force downward, the smoke, and the rocket goes up. Okay, so we know that the momentum, the conservation of momentum. So let's see, our momentum is equal to the mass times velocity. Okay, and let's say that we have a upward velocity. Okay, this is the velocity of the rocket. We have a downward velocity, which is the exhaustion velocity. Okay, so P is equal to mass of the rocket times the rocket, the mass of the rocket times the velocity of the rocket. Okay, and let's say that this is at time t. Okay, the p is going to be that. Okay, but let's say that we let a dt more. Okay, a delta t. So the momentum is going to be what? We're going to be the mass plus a dm, a delta m, which in this case is going to be negative. Okay, and the velocity well is going to be the velocity, okay, plus a dv. Okay, so this m is the m rocket. Okay, dm is a small m, which is going to be lost, and the velocity is the velocity of the exhaustion. Okay, actually, plus dt, it's mr plus dm. Okay, and v plus dv, that's the momentum of only the rocket. Okay, but we know that we actually have more, right? The the smoke helps. Okay, so what is the mass of the smoke? if if it gained dm, it's a negative dm. Okay, well, we know that dm is negative, therefore minus dm is positive. Okay, dm times the velocity, which is v, which is v minus vx. Okay, because the vx is constant in relation to the rocket, but if we're down here on the earth, we're going to see vr minus vx. Okay, so if we open this thing up, we know that m times v, which is the initial momentum, it's got to be equal to uh, m times v plus m dv plus v dm minus v dm plus v ex dm. Okay, so m times v plus m dv plus dmv minus dmv. Okay, and v. Okay, so then what happens? Mv cancel on both sides, 0. Okay, mdv and vdm minus vdm cancel out, and we have that the mass times dv is equals to minus vx times dm. If we then divide by this dt, we have m dv dt is equals to minus vex dm dt. So the variation of velocity in time times the mass is equals to minus vex times the change in mass over time. Now that this is m times a is equals to minus vex times m dot, okay, or just dm dt, and we know therefore that m times a equals f, so this is a force, and that's the force that goes up, that is pulling it upward, right? And so we know that if I want to increase my velocity, okay, I have to decrease the mass because it's going to be negative, and then negative times negative is positive, so boom, we increase our velocity. That's the conservation of the momentum for a rocket. And that's how a jet or a rocket works.